Hey everyone, and welcome back. When we talk about how different parts of a software system talk to each other, like a mobile app talking to a server, or two services talking in the cloud, there are two fundamental ways they can communicate: synchronous and asynchronous. Understanding the difference is crucial for building scalable and responsive systems. On the left, we see synchronous communication. This is like a direct phone call. When Service A needs something from Service B, Service A makes a call and then it waits. It pauses its own work and blocks until Service B processes the request and sends a response back. Only after receiving the response can Service A continue with its next task. It's simple and straightforward, but the calling service is idle while waiting. On the right, we have the asynchronous approach. This is more like sending an email or leaving a voicemail. Service A sends a request, but it doesn't wait for an immediate response. Instead, it sends the request to an intermediary, usually a queue or message broker. Service A can then immediately go back to doing other work. Service B later picks up the request from the queue when it's ready, processes it, and if a response is needed, it might send one back, perhaps also via another queue. The key is that Service A is not blocked waiting. Now, different protocols and technologies are used to implement these communication styles. Let's look at 4 key examples shown below. First, REST. This is very common for web services, typically operating over HTTP. When a client uses REST, it sends a direct HTTP request, like GET, POST, to a server at a specific URL. The server processes it and sends a JSON or other response back. This is usually a synchronous pattern. The client makes the request and waits for the immediate response. Second, gRPC. This is a high-performance framework for remote procedure calls. It uses protocol buffers for efficient data serialization. While gRPC can support asynchronous streaming, the basic request-response interaction often functions in a synchronous manner, similar to REST but often faster due to its design and message format. A client makes a call to a gRPC server and typically waits for the response. Third, AMQP, Advanced Message Queuing Protocol. This is designed specifically for asynchronous messaging. It's a brokered approach. A publisher sends a message to an exchange, which intelligently routes the message to one or more queues. Consumers read messages from these queues at their own pace. The publisher doesn't need to know anything about the consumers, providing strong decoupling. Fourth, MQTT, Message Queuing Telemetry Transport. This is another lightweight protocol often used for asynchronous communication, popular in IoT, Internet of Things. It uses a publish/subscribe model. A sensor or device, the publisher, publishes data, like temperature info, to a topic on an MQTT broker. Other systems or devices, the subscribers, interested in that topic receive the data via the broker. It's efficient for broadcasting information to many interested parties without direct connections. So, the main takeaway is, synchronous means systems wait for a direct reply, often seen with protocols like REST and gRPC for request response. Asynchronous means systems send messages via an intermediary like a queue or broker and don't wait, enabling decoupling and scalability, often implemented with protocols like AMQP and MQTT. Thanks for watching, and I'll see you next time.